right there. Whoa. All right, 1.3. Let's jam. Let's go. New functions and old functions. So what we have now is we have transformations. All the functions we've learned in 1.2, we go now into moving them around. Um, let's see. It'd be very similar to Algebra 2. Might add just a few little nuance stuff. Basically, that's what we're going to do. So you guys have a packet. I think this is the way the book writes it, but I think the packet I gave you is a little bit more succinct and a little more clear. We're good? So we'll probably just go off the packet that you guys have there. So if we go down the list real quick here, it's the first one is horizontal shift, vertical shift. Is that right? Then we have the negative that's in front of f of x makes a reflection of x-axis. Negative inside the function gets a reflection about the y-axis. And then we have the fun stuff now. The c value. If there's a multiple of c in front, which is kind of what they're saying right here. If there's a c value that's in front, it stretches it. The only thing is if it is greater than 1, it stretches, right? If it's between 0 and 1, it is a compression. I'm just going off the packet there that you guys have. And then what's the other stuff? Oh, if the c value or the function value is, or the constant, sorry, is inside the function, what letter did they use? K, is that right? All right. If it is between, notice it works backwards now, right? So if it's a function, if the c value is here, if it's greater than 1, it actually shrinks the graph. And if it's technically dividing it or between 0 and 1, it actually stretching it. Bless you. So it does the exact opposite, right, of what you think it does. Just like over here, right? I'm thinking like anything inside does the opposite. So if you say I'm going to add inside the function, it moves it to the left. Subtracting moves it to the right. You good? All right, let's jam with it here. So, all right, all yours here. So this is the way the homework goes. So what I did for this lecture, because I didn't like the examples in the book here, I just chose the even questions that are very similar to the odd questions. So, so y is equal to 5 f of x. Talk to me. What does the 5 do?
Uh, Stretches it.
Perfect. So here it is, a stretch v of x vertically by a factor of 5. Are we jamming? Cool. And if you want to write that in, that's fine. If you say, Mr. Gio, I know this is easy. And that's fine. Just take a look at it here.
What's the difference between stretching it vertically and stretching it horizontally?
Stretching it vertically would be this way. So it goes up faster or down faster. Horizontally, when it just widens it out. But so Karis has a good question there. Yeah.
If you shrink it vertically, it would be the same as stretching it horizontally.
Let's go with it here. So if I were to that is interesting. I almost want to say, let me think about that just for a second. Okay, before I answer that. I'll think as we do in the lecture.
Get to the graphic.
Because if you just, I think it's just a multiplication factor, but I gotta think about it, especially with parabolas. All right, those would be the good example. B, let's pick on people. Luke, gotta pick on people from the back. All yours, go. What do we do with it? What's happening to the graph?
Right to the 5.
Cool, yeah, there is a move, or you can say there's a shift, right? Shift f of x to the right. 5 units is good. White, all yours, sir.
G. Just flips it.
Flips it across the.
Okay.
Perfect. Are we good, guys? Are we good? I can go faster here. D. Holden, all yours.
Subject new x-axis and vertical stretch.
Sounds good by me. Reflected by the x-axis and stretch vertically by a factor of 5. Done. Adrian, all yours for E. I know some of you guys are writing it down, so I'm just waiting a little bit here. E.
For change, shrink it by a factor of 1.5.
you would shrink it by a factor of 5. Like, so it'd actually go, so you would say you can stretch it by a factor of 1/5, right? Because the 1/5 means you're gonna bring it back, right? So it's kind of how you say it. So the bigger the number, if it's bigger than 1, it compresses it. So I would say this, Adrian. I would say because it's bigger than 1, I would say a compression fx horizontally, whoa, by a factor of 5 because it's bigger than 1. Cool. Okay, are we good with that one? Jamming. Lila, you get F.
Stretch by horizontally. Well, vertically
Vertically perfect. Uh-huh.
to, uh,
There you go. Yep, perfect. We go down because it's outside the function. Awesome. Vertical stretch by a factor 5 and shifting 3 units down. Are we good? Jamming. Let's go. Okay. Here's what I want you guys to do. Again, this is just getting used to graphs, right? This is kind of what we're doing. Can you guys draw that right there is f of x right there. I need you guys to draw f of x plus 4.
What is the equation f of x?
And f of x is this graph right here.
Yeah, but like, is there an equation for it?
It's the graph itself. So we're doing some visual stuff of actually moving things around spatially. We good? So can you guys redraw this? What, pink line or red line, whatever it is, redraw this line. Knowing that the new graph is going to be f of x plus 4. Whatever that means. Okay, let's give it here. So Katie, all yours here. What is x plus 4 going to do to our function?
shift horizontal compression. Or
I'll go with shift because it's x plus 4, right? There's no multiplication. Perfect. Yeah. So we're going to shift this guy to the left. We good? Can you guys redraw this graph, shifting this guy over to the left 4 units? I got this right here, right? We're going to go all the way back down. So I'm thinking this little space right here. This guy, which is at, let's see, -1, -2, -3, -4. This guy, this little dot right here is going to be at -8 now. Is that right? So it's just everything is shifted this way 4 units. And again, just working on our spatial abilities here. So this dot now is going to be at -8, 0. True, true. This dot, where's that guy going to be now? -4, 4. About right there. Now, this one, -2, 1. Is that right? Perfect. And last one, 0, 2. Perfect. So there it is. There's that one. There's that one. There's that one. And that one. And then we just connect dots. We good? That's kind of what we're doing. Just getting us used to some. Oh, I should have done it the other way here. All yours, B. So think of B is and graph it. All yours. Yep. 4 units high up or higher. and give you guys about a minute or so to do it. I will check B, but if you say, Mr. Najib, I know I got B correct. Okay, then all yours for C. We're good. And can you guys graph all four of them? Eventually here. That's what I want. All right, I'll walk around, just checking on you. And of course, D is the crazy one. So if you guys can do D, great. If you need to write out what you're doing first, that's fine. Like B going up, shift up like 4. All right, if you're done, check with the person next to you. And if you don't want to check with the person next to you, I can check for you. Directly apply. Yeah. Look, maybe I do the flash now. Questions is not right. Yeah. So, sure, let me explain those. Because it's vertical stretch, this little guy never gets stretched because it's technically at 0. But technically what you have is if this guy goes up to 1, we stretch it, now it goes up to 2.
Okay.
So anything above the x-axis gets stretched up further up. Anything that was below the x-axis gets stretched further down by whatever that x-axis is. And the other way to explain it is you really just multiply the y-axis by that number. And the x coordinate remains the same, huh?
That's.
Yeah, because if you multiply, it almost like it stretches it out. But if you shift it, then this graph just goes up. Right? There's no change to growth here. So as you guys do that, I'm going to do a little something here. So curious to answer your question now. So vertical, you're saying what, vertical stretch or horizontal stretch? How are they different?
Yeah.
Sure, let's do that here. So let's do just these 2 points here, 2, 4, right? And on 1, this is f of x, right? So if you have let's say we had a vertical compression, right? We're gonna go half the amount. And so this is gonna be, here's your vertical compression. If that's the case, we got ourselves here, this is 1, 1/2. And this is 2, 2. If you had a horizontal, let's see, I'm going to say it like this here. So this is 2, because we want to compress it. No, we're going to want to get to that point right there here. So it's going to be 1, Ah, let's do that. Should be different though. So if I put one in there, it's still, yeah, let me think about it a little more. So it's still stuck because I think it's going to stretch out too far and would, and then I can do this. There's my stretch because that will make this to be 1/2, right?
Hmm.
And then if I go the next one, that's not going to give me 2 in here at all. So let me think about it a little more. So I can get some dots to be the same, but I can't get all of them to be the same. All right, B is good. Let's go. B, here it is. Toom, toom, toom. Are we good with that? We just went up 4 units. Now the top of it is at 1, 2, 3, 4. Ah, the top of it is 0, 8. Good, good. Jam, jam. Are we done? Did you guys all graph B already? Sweet. Okay, C. Oh boy, here it is. It goes like this now. We're good there. So notice this little guy at -4, 0, it stayed at -4, 0, right? That does not move because if you multiply 0 times 2, it's still 0. Did I tell you the story about multiplying by 0? No.
Oh,
Oh, my dad, I used to mow the lawn in front of our house and pull weeds on Saturday mornings. That was a fun experience. So he said, son, I love you so much. I'm gonna like triple. I'm gonna triple how much I pay you on Saturday mornings for a lawn.
wow.
That was not fun. Like, Dad, that's cruel. Okay, so now, oh, we got this one here. So let's see. Are we on D now? Is that right? Let me move this around. I don't like the way I set that up in the first place here. So I'm going to go here, here, and here. There you go. That's what I'm doing. Okay. Whoa, that was weird. Okay, and we got ourselves. Oh, anybody? Who are we picking on? Maddie, are we picking on you now? Yeah. What are we doing with D?
You're shrinking by 1/2.
Vertical shrink by 1/2. Yes, absolutely. Okay, that's the 1/2 part, right? That's cool. That's the negative part. Yep. Heck yeah. Awesome. We're jamming. Okay. So we're going to do 3 different transformations. Here they go. So that was the 1/2, right? Everything got squished. Remember the 0 still 0, right? This only goes up to 2 now. That's at 1/2 now. That's at 1. And now we go reflect about the x-axis. Are we still good? And then we go 3 units higher from each of those green dots. So 1, 2, 3. Doo-doo. 1, 2, 3. Doo-doo. And we got, okay, that's a half. So kind of careful here. So there would be 1, 2, 3 right there. And this would be 1, 2, 3 right there. And I connect now at that point. Cool. Raise your hand if you guys got that before I did. Sweet. Awesome. Mm-hmm. Sounds like a volleyball serve. Okay. We're jamming. Are we good with those? Sweet. Okay. Next. And again, I'm just taking either examples or problems themselves. Now, based upon that, a little bit tougher, and it's kind of in a different form here. So 1 minus x squared. Can you graph this guy? You know it's a parabola. Yes, awesome. Hey, if you're getting that, that's cool. Seriously, this is awesome. All right, I'm going to write in something here real quick here. So normally, this is the tricky part. Normally, we don't like, or we actually like to have the function first and whatever goes afterwards, right? So this is technically Ooh, I'm gonna try something here, just real quick here, just out of curiosity. Highlight X. Ooh, this would be fun. Okay, so if I'm gonna graph this guy, I'm gonna change it to this because that's the way I normally see things. Are we good there? Sweet. Okay, so then we can graph it here. So we got this, da da da, da 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 da. That would be x squared. And notice I also kind of move from kind of like from left to right. I'm going to do this part first. Whoa, okay. I don't like that now. Now I got to do this one. Hold on. I'm confused. I did rewrite it.
That was helpful for me when reading to rewrite it.
Mm-hmm. Except I just need to know that sorry guys. I just need to know that I wrote things on. Be helpful. So this guy right here, rewriting it like this helps a lot. Let's go this way. So the flip of it, now we have ourselves negative x squared, is that right? And then all we do is we move it up 1 unit. So how about negative x squared plus 1? Are we good? So let me see how that works now. Yep, and I wrote those in. All yours. Oh man, a trig function? What? Go for it. Gotta go all the way back to trig class. Oh, and what does the 3x mean now?
Does it mean that it's free or
Something like that. Or 2 pi divided by 3.
Oh, that's the,
That it controls the period. Is that right? Yep.
it's on side?
the signs start at 0 or
Oh, it's 0, 0. Mhm.
and then cosine
Original.
starts.
0, 1. Yeah.
Wait,
Mhm. Absolutely. All right. I know this has been a whole year ago. So can we? Let's see. When was this? This was drafting. So this would have been December last year. Ooh, all right. So if we have forgotten, sine curve goes like this. It goes 0, 0, starts 0, 0, goes up, goes down, and gets to 0 again by the time it gets to 2 pi. And then we got ourselves 1 and negative 1. True, true. True, true. Okay. Then we have this deal, though. So notice also the trig functions. I guess you can go from left to right. You can do the 4 first. Actually, yeah, we do the 4 first, right? We do the expansion, then we do that. But dealing with that little 3 there, we just take the 2 pi divided by 3, right? Because remember with trig functions, it's all about scaling, right? We can actually just scale our graph and we're done. So if that is 2 pi over 3, that means this is pi over 3. And if that's true, still going up to 1, going up to negative 1. Cool. We just changed our graph. Technically, though, if you guys think about it, right? By dividing by 3, we made like this kind of function, right? It would go like this. That's it right now, right? We've made it that compressed. We've compressed it by 3 times. Or you could say it goes 3 times faster. Isn't it kind of crazy? Like the outlets that we use, right? They're called AC current, right? Which means electricity actually is not just it's stagnant, right? It actually moves back and forth. And the back and forth motion is the thing that actually makes electricity, right? And gets the filaments going. Um, and that is going to be, we have a 60 hertz system. So it goes back, goes down and up, right? 60 times in a single second. So that's why it actually allows whatever filament we use on the lights to actually work. Kind of weird how that works. Let's see. What's some fun stuff though?
I noticed that they're like losing heat.
Oh yeah. Um, in Europe though, Europe, their electricity system works on a 50 hertz system. So all their filaments and all that stuff are slightly different. And so that's why if you go to Europe, you actually do need like you need an adapter. And their electric plugs are not slots; they're like little holes, right? So they have a whole different electrical system. I guess not to confuse the two, right? But we essentially live on two different electrical systems. One's a 50 hertz system, one's a 50 hertz system.
Divisible by 12. It is.
Mhm. And I wonder is because they're used to the metric system, right? Because metric system is divisible by everything is by tens, right? So then like, well, electricity, let's do it by five. Let's cut it right in the middle. Right. Um, oh, then my brother, he was a little smart there. He bought a washing machine from Europe, which works on a 50 hertz system. He brings it over here. It's a 60 hertz system. So the washing machine, it's a dishwasher. So it works hotter, right? Everything is like 10% more, right? Or even more than that, right? It's like 50 goes to 60, right? That's 10, it's 20%. Everything is 20% faster, hotter, everything because of that. So his dishes come out really, really clean. Okay, so let's go there here. So 2 pi over 3, and now we go up to 4 and down to -4. Are we good there? Cool. And do all yours for this one. This one, you may have to look at your functions from 1.2, maybe. And think about what does the x minus 4 do to this function? And think about the original function as well, right? The original function is 1 over x, I believe. Yeah. So volleyball people, what'd you guys do for 2.5 hours on?
Read Gilgamesh, then I read Bird of the Iliad.
Oh, cool. Okay. For class, for English class. Time to get some homework done. Yep. I know when my kids were playing sports, I just told them this is the best time to actually do homework. So heck yeah, 2 hour drive and 2 hours back, pretty much get 4 hours of homework done. Like, Dad, I'm the only one that's doing homework on the bus. Like, that's okay, man. Okay, are we good? So we have a reciprocal function that looks like this from our notes the other day, is that right? And what does that little -4 do?
Do you have to put in the dotted on 4?
Technically, yes. Yes, you'd have to put these dotted lines in because if you don't, we don't really know if it's a vertical isotope or not. When you put the dotted lines in, then it's for sure a vertical isotope. Now the book, whenever whenever it goes like this right here, right at the x-axis or the y-axis, it never puts in the line. I don't know why. I think it should in my mind.
Maybe it does. Just
Because it's on that.
It's on the black line and you can't see. Maybe. I've tried to look. I try to zoom in to see if there's anything there, and I just don't think there's anything there. But technically, yes, there is a word. There's dashed lines coming down. Okay, boom. Next. Craziness. Okay, so think about what? What in the world? So hold on, wait. This is not a function that we're used to even, right? This is x squared minus 2x. How do we do this one? And so at that point, there is a way to do it by transformations. It's a lot more difficult. We're good. So then we might as well just think about the shapes of the graphs. Think about where our zeros are. Think about how things are moving along here. So we get ourselves this guy. So if we wanted to, though, we can do a little bit of this here. So do you guys remember completing the square?
Oh,
I thought I'd heard some reactions like, oh. So -2 divided by 2 is -1. We square -1. We get ourselves
1.
1. And whatever do on the inside of the function, we have to do the exact opposite, right? On the outside of the function. All right. So we got ourselves this. Tell me if you guys agree. Write it down if you need to. I got myself that. That is the function that I'm graphing. Oh,
square root.
Just take out
Clean
x
that.
out of the original function. So you have x parentheses, x.
you can. The only problem is, let's see, that's one way to do it. Yeah, you can do it by that point. You're looking for zeros. You're looking for things like that, right? What we want to do is we want to think about how we know graphs to be. And so we're trying to do a bit of transformations, I guess. Yeah. Okay. Are we good with the first step? You guys good?
Hmm.
I like it.
Mhm. I take, I give, and I take away. Oh. Okay, so this little graph right here, can you guys graph this guy? All right, but with the absolute value function, you do have to pay attention a little bit where the zeros are. We good? Because of the absolute value issue. So, can I pick on? Matt, I already picked on you, right? Karis. Karis, tell me real quick, what's happening with the -1 and the -1?
So right, like this.
Uh-huh, because of the... Hey, cool.
Down, but since it's an absolute value, there's that.
Okay, yeah, so we'll get to the absolute value in just a second here. But are we okay with 1 to the left? I'm sorry, 1 to the right because of this guy. And then we're going to go 1 down. So can you guys graph at least that function only? Ooh, all right, let's graph that. Blah, blah, blah. We know that one, vertical. So we get ourselves this. So I did a different way with the vertex. Don't need to do it that way. We're just going to go like that. We good? Okay, just being extra careful to see where the zeros are. That's all. And so because the absolute value, as Kara said over here too, this little guy right here just needs to flip the other way. So da 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 da. How about this? Oof. Anybody?
Weird.
What does that look like? A tooth? Everybody okay with the tooth there?
What if you did the absolute value of y in function? So then it would flip. You know, it wouldn't be a function.
What would it be? What would it do?
So if you flip, you'd have to get a plus or minus on that side, right? And then once you get that, then you're going to get both the x and y coordinates. Go into it a little more depth, or no? Are we good? Good. Maddie, sorry, you were saying something. Go ahead, talk to me. Okay. Boom. Okay. That was transformation of functions, guys. This we actually did already in our diagnostic tests. Remember that? So this is called composition of functions. We're going to go a little tiny bit more in depth on this. And then also we're going to talk about their domains. So, and we have 20 minutes to do so. Let's jam. This guy. So what I want to do is I want to stuff the G function into the F function.
Okay.
So for A, it's this right here. It's fog. So F of G of X. And it's F of all this good stuff here. We did that, and we're going to go a little tiny bit more in depth on it. Okay, that's cool there. And then what do we do with f? Subtract 2, that's it. So this is just all this function right here minus the 2. And then, of course, we have to simplify it out, which is, tell me if you guys, tell me if I'm going too fast. We're good? I know some people are writing it down. Some people are just like, what, letting it sink in by osmosis. Is that what it is? So part calculus, part chemistry class right now? All right, B. B is going the other way. So this is one thing we got to notice. If you go f of g, is it the same thing as going g of f?
Oh,
No.
So here is this guy now. So the function side is x minus 2. This one's a crazy one to do. Because, right, we have that x squared on our g function, then we have the x itself. So here's the writing it out here. This would be x minus 2 to the second power plus 3 times x minus 2 plus 4.
that means we're not multiplying them.
No, we're stuffing open dot, not closed dot. Yeah, if it was a closed dot, it would be multiply. Open dot means composition. And we say fog and golf.
Senior fund.
All right, we do have to simplify this out. For the homework, though, I'd like for you to simplify it out, right? Cool. Are we good? Jamming. So I just kind of did it. I multiplied everything out. We good there? And then bring all the things together again. And C and D, what is that talking about is this. Talking about the fact that you can nest the function inside itself. You can do that too. And the easy one is f of f. What do you guys say? Would that be FOF? FOF it is. X minus 2 stuffed into an x minus 2. Interesting. What does that do? So if you subtract 2 once, and if you nest the function, what are you going to do? Subtracting 2. So now you got to subtract 4, right? If we did f of f, ooh, that subtract 6. Yeah, so it's just reiterating the function all over again. We found out in mathematics, here's one of the things that we do. Nature, right? It's refractive, right? Which means it grows on itself, right? And so when we found these, we call them reiteration functions. It just does its own thing over and over again, especially when you add a multiplier in here. Then you actually can kind of see how something can grow in a sense, right? Because it's growing on itself, which is kind of cool. Okay, the crazy one, if you choose to accept this, it's going to be GOG or Goog. Little too crazy, but if you want to, all yours. I guess you'll have fun like this on the homework. It's this function inside itself. Is that right? So let's just do the first iteration of it. That would be x squared plus 3x plus 4 to the second power. True, true. Multiply by 3 times that same exact function, and then add 4 to it, and then you have to multiply all that out. We will not multiply all that out, especially that x squared plus 3x plus 4 to the second. Adrian, I give you commission to do that.
All right.
And I guess I'll show the answer real quick here. But it's all that. Whoa, look at this. This is how long it is. Blah, 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 blah. Blah, blah, blah. Mm-hmm.
Oh, no.
Let's hide that. Okay. Okay, now let's go a little bit step further here on this. Now we have 3 instead of 2. And here's what we got. We're going to go backwards. We good? So here's my function. So all yours, can you guys do this one? So I want, how do we even say that? Fog, huh? All right, can you guys do this one all the way through? So Adrian, I'll have you do the satisfaction of doing that one all the way through that. So it's fog, huh?
Does that mean it's like at the points and then you put in g of x and then a g of x you put an h of x?
Yeah, it's so triple nested here.
Mhm.
All right, I'm checking time because time on this one. Okay, 10 minutes. Too easy.
It was just 1 squared 2. I did it right. I did it wrong.
So you had to square 1 minus x, is that right?
I did think it was interesting how since 1 minus x was like
Flip it.
opposite.
Mm-hmm. That we normally think about, right? So h goes in, then h is being squared, and then you almost just have to do that off to the side, maybe, or you can just do all at once here. So are we good there so far? Cool. And then it's 2x minus 1. So then it's 2 that guy squared minus 1. There it is. Adrian, go ahead.
But you know how Pascal's triangle, it like goes from the one variable and then as that variable isn't used as much, the next variable kind of takes over. I don't know if that makes sense. Like it's like
Yeah,
square two
yeah.
and then it goes to-
Mhm.
I was wondering if that's how like forces and gravity work, like when you shoot something out of a cannon, like that force runs out and then gravity kind of like builds up and takes over, or is it like different?
No, because it's more I'm thinking. No, I think it's more constant though, right? Because if you shoot something in the air, right? Gravity is just
0. That's the same as the force of the same as the
the
gravity
very
pulling me down,
The
then,
top of the art.
yeah, that's
Nothing's
0.
with-
Oh,
so yeah, I'm thinking slightly different. Yeah.
I'm listening.
Maddie, so explain a little more. How come?
Well, I think like what you said, at a certain point, it doesn't like, there isn't enough, like, the x to finish going to the other side, it's then like a second number.
Oh, like takes over, right?
Yeah.
Okay, got you. Yeah.
Because the x is always there, it's just being multiplied by like 1 or like by 0.
Mm-hmm. Okay, yeah, I could see that as more like iterations. Yeah.
Like,
I'm just thinking like you know how Pascal's triangle, right? You go from like 1, 4, 6, 4, 1, right? So in the middle, you almost have the biggest,
Yeah.
What'd you say? The biggest amount of magnitude, right? But when you shoot an arrow, right? The magnitude is constant, right? The force is applying further and further. Yeah, when it hits the 0, you're at a certain amount, which now is balanced, right? But then the force is still applying further and further, right? That's why it's going to go down. So it's almost like it goes down. So I can see that, yeah. So not so much Pascal's triangle of 1, 4, 6, 4, 1, where it goes down, right?
inverted Pascal's triangle.
But then, huh?
Inverted.
True, yeah, uh-huh.
I was just thinking about it.
6,
Mhm.
4, 1, 1, 4, 6.
Where it's like height, yeah, you can do the height with it, yeah. Because it's so with anything that goes up, right, and comes down, right? That would work because it would give you almost like the height of it, yeah. Right. It comes down. All right, I think we're gonna go do this one here. So now let's go. We got to go backwards, guys. So here it is. I'll give you this, and I want to know what are the 3 functions that are nested. So you want to go backwards out. So the question is, give me f of x, g of x, and h of x individually. So what is the most inner function we have, or the most outer function we have?
Most outer would be 8 root.
Yes, the eighth root. So if we did all that, so you could start off with the outer function. Notice it's the eighth root of something, right? Then notice inside there's a x2 plus something, right? And then there's a absolute value of something. So we start off with the inside function, we move ourselves out. So in this case, if I define my inside function as absolute value of x, then I can define the next function to be 2 minus that thing that I just made. And then from there, I can say that's the thing I just made, which is the eighth root.
Yeah.
On the homework, though, I think on the homework, there's an ambiguity. You could actually do it like 2 different ways. This one you couldn't. This one's kind of stuck because there's only 3 iterations of things. But let's say there was a multiplication by 4 over here, right?
But hypothetically, f of x be the 8th root of 2 plus the x, and then g of x just be x and h of x just be x.
Yes, true. Yeah. So it's not going anywhere. Yeah. But you could do that. Whole bunch of linear functions either. Yeah. So there is some ambiguity here, especially if there's like, I can add a 4th function. Where do I add that 4th function?
Or it could be like +1 and then the next one is -1.
Oh, yes. That's right. To undo stuff. Yeah. Okay. So now let's see, just some interesting questions here. So on the homework, at the end, usually in the, towards the end of the homework, we have these kind of just some questions about functions, a little abstract. So here it is. Suppose that f is even and g is odd. What happens if you multiply the 2 functions together? And so what you have to do is just come up with, these would be kind of the fun homework questions. If you can't figure them out, that's okay, right? But at least kind of try. Probably should work out some examples. So like, what's the easiest even function? X squared, right? X squared. That's the typical easy. What's the typical odd function? X cubed. If I were to multiply these guys together, what do I get? X to the 5th, right? Because whenever we add exponents. So interesting. So then just do another few more examples. Is that true all the time? If I were to multiply any even function, any odd function, do I always get an odd function? Cool. And so it will be odd. So just do some examples on them and see if it.
If it was f of g though, then it would be even.
Oh, interesting. Yes. If it was f of g, it would be even at that point. So yeah, there'll be some kind of just some questions like that towards the end of each of the homework assignments, or most.
Odd of you is. Whatever.
I am not sure. I got to think about that too. My hunch almost says no, there is infinities that are double in size, right? So if you have all the integers forever, right? So 1, 2, 3, 4, 5, right? And then we have the infinity called all the even numbers, right? So technically, the first infinity is double the size of the second infinity. So in mathematics, we do talk about that. So like, hey, that's double of that infinity. But what does that mean? But then at the same time, if you go to infinity, it's still the same number. So 2n equals n in infinities.
I think we should ask too many questions about infinity. Seems.
I think it's
No, we're all good. It's fun to explore. I don't think we're gonna go crazy with it. Okay. Let's see. What time it is, Guy? Oh, no time for a short video. So we are out of here. It is 10 o'clock. Actually, 9:59, but close enough.
Mr. Handel.
You